How's everybody doing today? I'm going to talk a little bit about conditional probability. Some of the core fundamental concepts of conditional probability. Now, to do that, I am going to illustrate this with a bucket of balls. So here's my bucket. And I'm going to put 6 red balls, 1, 2, 3, 4, 5, 6, 6 red balls, and 4 blue balls in this bucket. 4. Now the experiment is going to be something that we're going to do together. It's going to be, I'm going to pick the first ball, and I'm going to draw a ball. Let's do that in black since they're red balls. And I don't know what this first ball is. So this first ball, I pick it, but I don't know what it is. Now the second ball, you choose the second ball. You pull out a second ball at random, and it turns out that that ball is blue. Now, what we're going to try to find is the probability that the first ball is red, given the second ball, which you just chose here. The second ball you just chose. Second ball is blue. We're going to try to find that probability. Now, to do that, we're going to take a look at a couple different approaches so you can get a full appreciation of what this conditional probability is all about. Now, first, let's take a look at the events. There's 2 events here. The first event is event A. Event A is the first ball is red. Now, event B is the second ball is blue. Now, each one of these have probabilities with them because they're events. For example, that second event can be a blue or a red. So let's illustrate this. Let's try to get a conceptual feel for this. Let's take a little bit of look at set theory. Let's take a look at set theory. Now, when we do that, let's take a look at the 2 events. You got event A. Now, event A is either true or false. So event A, it's either going to be red or not red. So event A is, the event is it's going to be red, but that has a probability with it because it has a lot of outcomes. So now that's the event A, and event B is the second ball is blue. So the second ball is either going to be blue or not. So that event's going to be true or that event's going to be false. Now that intersection there is the intersection where both are true, where the first ball is red and the second ball is blue. Now, what we want to try to find is that probability there, that the first is red, given that the second is blue. Now, if you look at that, you see here, given the second is blue, the first ball, now we want to find the probability that A given B. So what we want to find is the probability. Let's do that in black. Probability of A given B. Now, what is A given B? Well, A is the first ball is red, and B is the second ball is blue. So probability that the first ball is red, given that the second ball is blue, is equal to on the bottom, given that it's blue, that's our total space, so that's probability of B. Now what we want to try to find is that intersection, which is A and B. Now we just came up with a conditional rule here that's known, but we did it through intuition, just by looking at the sets. So now that's what we're trying to find, A and B. Now let's hone in on, let's try to take a look first at this piece right here. That piece right there. We're going to look at that piece. Let's come all the way over here. Probability A and B. Now, A and B. Now, let's look at, we know probability A given B is in this case, when we're going through the set theory and the probability rules, it's a little harder to find. But let's look at the probability of B given A. If we look at the probability of B given A, we know by the rules, right here, we just established a rule, it's equal to probability of A and B divided by probability of A. Now we know the probability of A. Probability of A is just the probability that the first ball is red. Well, that's 6 out of 10. And we know the probability of B given A because that means the probability says that's the probability of the second ball is blue given the first ball is red. Well, that is 4 over 9. So now the probability of A and B is equal to 4 over 9 times 6 over 10. Okay, now that gives us the probability of A and B. Now, what's probability? Let's look at it a little differently. What's probability of B? Probability of B says that we want the second ball to be blue. Well, here we are right here. Second ball is blue. We really can't determine what that probability is unless we know what the first ball is. So we got to do two cases here. We got to evaluate both cases. So let's just draw that out a little bit. Let's draw the first case. It can be a red or a blue. Not to be confused there. So the second ball is also a red or a blue. Sorry for using red here, but we're just trying to illustrate this tree. So now we want to find the probability of the second ball is blue. So what we want is probability the first ball is red is, first ball is red is 6 over 10, and the second probability the first ball is blue is 4 over 10. So here we want the probability of blue. So we want, that would be 6 over 10 times, now which probability that second was going to be blue? Well, the first one's red, so it's going to be 4 over 9. Now, what's probability over here? This one's going to be blue. The second one's going to be blue. Well, the first one is, it's 4 over 10 for the first one, and the second one is going to be 3 over 9 because the first one was blue, and that left us with one less blue, which is 3. Okay, so that's our tree. Now let's put that together here. Let's put all this together. If we put this together, we get, up top, we get 4 over 9. Let's do it in black. 4 over 9 times 6 over 10 over And if you notice, this is also probability. This is 4 over 9 times 6 over 10. Let's take a look here. What this is red and blue. So this is red. So first one's red is event A. So it's A and blue. So that's A and B. So that's what this one is here, A and B, which is, this is also probability A and B. That's why these two here are the same, plus here. Now this one, that is not A and B. That happens to be called the total law of probability. But we're looking at it from an intuitive approach. So now this number here is 4 over 10 times 1/3. Now if I simplify a little bit, simplify my fractions, and just to save a little time, this comes out to be 2/3 if you do the math. You can see that's 4 over 10, which is 2 over 5. That's 2 over 3. That's 15 on the bottom. You can multiply top and bottom by 15. You wind up with 4/6, and then you get 2/3. Just to save a little time, I will leave that to you to check out. So that's 2/3. So now that's one way of looking at it. Now another approach, which is a little bit more visual, is to look at this directly and say, okay, so the first ball we chose, we don't know what it is. So we want to know the probability of A given B. Probability of first is red given the second is blue. So here we are back here. So we know that second's blue. So let's throw that one in the trash can. Let's put that in the trash can. That's gone. Now we're left with, instead of 10 balls, we got 9 balls. So let's look at these 9 balls. We have, that ball's gone, so now it's 3. So we're left with these 9 balls. 9. Now, how many of them are red? We want to know, out of those 9 balls, what's the probability that that one right there, which is sitting all by itself in this, out of the box, out of the trash, out of the bucket, we want to know what is the probability that's red. Well, that's 6 of them here, so it's 6 over 9, which is 2/3. So 2/3, 2/3. We get the same approach. Notice how we only used one formula here. This conditional probability formula, which we intuitively derived it. So that's the first look on conditional probability. I hope this provides additional insight into your understanding of conditional probability and motivates you to learn more about this topic. In another lesson, I will demonstrate a little bit more, slightly a little bit more complex example. So I will see you in my next video.